we've got to prove this identity to start with. So we're definitely going to start with the left-hand side and try and get to the right-hand side. That's going to be massively help if you know your double angle formulae here. So I'm going to replace cos 2 theta. There's actually three versions of cos 2 theta, but I'm going to replace it by cos squared theta minus sine squared theta. There's also 2 cos squared theta minus 1 or 1 minus 2 sine squared theta. Sometimes they're useful. But I'm going to use this one here, especially because there's a 1 and maybe I can combine, maybe I can also use the fact that sine squared plus cos squared is 1 later on. And then sine 2 theta is 2 sine theta cos theta. Now, if you don't know those, then you can derive them from these addition formulae. So you just need to use the plus in both cases and then let b equal to a. So we'll be get sine 2a is sine a cos a plus cos a sine a. That's the 2 sine a cos a or 2 sine theta cos theta. And then here, if I let b equal to a, cos of 2a is going to be cos a, that's my cos squared, minus, because I follow the top path, sine a, that's my sine squared a. Okay, and then I'm going to also substitute in on the bottom. So cos 2 theta is going to become cos squared theta minus sine squared theta, but this time I'm plussing that term. But again, plus 2 sine theta cos theta. We know the final answer has a tan theta in it, no double angle formulae. That's kind of the motivation for trying to do this. Okay. Well, 1 minus cos squared minus sine squared theta, if I get rid of the bracket, actually the minus cos squared theta stays this because this becomes plus. And then 1 minus cos squared theta is sine squared theta. So I can write it as 2 sine squared theta plus 2 sine theta cos theta. What's on the bottom? I've got 1 minus sine squared theta. So actually that becomes cos squared theta. And I get 2 cos squared theta plus 2 sine theta cos theta. Now we've got some common factors. We didn't have that before. So on the top I can factorize out 2 and the sine theta, leaving me sine theta plus cos theta. What's on the bottom? I've got 2 cos theta as a factor, leaving me cos theta plus sine theta. But these are the same, so they cancel. The 2's also cancel, and that gets me to sine theta over cos theta, which is tan theta, which is the right-hand side. Proof complete. Next part says, hence solve for theta to 180 this equation here. Now I do not want to start playing around with this. I want to use the identity that we've got up here. And so it follows, if I replace theta by 2x, then I'll get 1 minus cos 2 times 2x, that's 4x, plus sine 4x over 1 plus cos 4x plus sine 4x, and that's actually going to be identical to tan 2x. I've just replaced all of my thetas by 2x. So I want to actually solve tan 2x equal to 3 sine 2x for 0 to 180. No, we're not actually including 0 or 180 and giving our answers to one decimal place. Okay, so now I'm going to write tan 2x as sine 2x over cos 2x is 3 sine 2x, multiply through by cos 2x. You've got two options at this point. You can either cancel out sine 2x, but consider it equaling 0. And then that would leave me 1 equals 3 cos 2x, which implies that cos 2x is equal to a third. Or the other way to do it, if you prefer, is we could minus we could minus whichever one we wanted. So I'll do that. And then we can factorize out the sine 2x. And we get to the same answer. What I'm trying to say is if you do cancel out the sine 2x's, you've got to consider it equaling 0 as well. Okay, otherwise you're actually missing some solutions. So let's solve it. Inverse sine of 0 is actually 0 or 180. Oh, there's one thing I forgot to do. I haven't changed the range yet. So because we're solving for 2x at the moment, we actually need to go all the way up to 360. I need to double that range. So I'm going to get 0, 180, 360. But remember, it doesn't include 0 or 360, so I'm actually going to reject these ones, which means x is going to equal 90. That's the only solution from sine 2x equaling 0. And then for the other one, I'm going to get 2x is inverse cos of a third. Make sure you're working in degrees here. Which gives me 70.528. Or we can draw the cos graph and see the symmetry going on. This, I've just basically worked out this point here. It's going to have the same value as that one. It's 360 minus 70.528. 289.471. If you use cast diagrams, then we've just worked out this one. We want that one there. So that's why I want to go all the way around here. That's why it's 360 minus the 70.528. Okay, now I just need to divide through by 2. So since I've got it here, I'll just divide that one by 2 first. 144.735. I would advise getting all the solutions to 2x before you start dividing by 2, on this side anyway. 70.528 gives 35.264. Okay, so finally x is 35.3 degrees, 90 degrees. By the way, there was nothing else in the range here. I was only going up to 360, remember, for 2x. I didn't need to consider any more. Or 144.7 degrees. Okay, well done if you got those. If not, I hope you're happy with my explanation.